Let's do some more examples of applying the chain rule. Here I'm looking at a function, h of x, which is a composition of functions. First thing I want to do is split it into the inside and outside functions. The inside function looks like it is inside of these parentheses, so I'll write that as the inside function. The outside function looks like it's just this exponential on those parentheses, so x to the fourth. And if we weren't 100% sure if these really were the inside and outside functions, then we would really benefit from trying to recreate h of x. So we're going to check that h of x really is the composition of the f and g functions that we've identified, meaning that I would take the g function and plug it into the f function. It's really important to check that we have the correct inside and outside functions, because if we picked them wrong, then we wouldn't come back with the correct answer. Let me show you an example of picking the wrong inside and outside. Maybe I think that the inside function is 2x cubed, and that the outside function is the rest. If I tried to recreate h of x using these inside and outside functions that I've just identified, a disaster would happen. So if I tried to stick g of x into f, where I picked f to be 2x minus 1 raised to the fourth, that composition would actually look completely different than the h function that we found. Now, it might be worth reviewing compositions of functions because there's a lot of mistakes that can be made here, and becoming good at breaking down the layers of a composition of functions. It really comes from practice. So you get better with it the more you practice, and every mistake you make, you'll learn from it. So if you pick the wrong inside and outside functions, try not to get frustrated. Just remind yourself of what function kind of duped you. Which functions are you having trouble identifying in your compositions? But in this case, looks like we picked the right inside and outside function because we were able to recreate h of x using a composition of f and g. And our chain rule says that if we're taking the derivative of some function h, where h is a product of two functions of x, not a product, a composition of two functions of x, then we're really taking the derivative of that f of g of x. And our chain rule says take the derivative of the outside, but then go back and plug the inside function into it, and then multiply by the derivative of the inside function. In our first example for this section, I used u as an intermediate variable, and we can do that here if we'd like, but it really doesn't make a difference. There's another notation that we can use to show us the map of how to do this chain rule, and that's using the prime notation. So we can do f prime of g of u times g prime. And sometimes you'll even see this with an x, g of x instead of g of u. All right, so remembering our 4 steps for finding the chain rule, first thing was to identify the inside and outside functions. We just did that. The second thing was to take the derivative of the outside function. I'm going to call that f prime. F prime in this case would look like 4x cubed. Also part of step 2 was to plug the inside function into the derivative of the outside function. which that would look like 4 times our inside function cubed. Then we move on to step 3. Step 3 is the derivative of the inside function. In this case, that will look like 6x plus 2. And then our final step, step 4, was to multiply the result we have from step 2 to the result we have from step 3. Let's take a second to look at some common mistakes that might happen. One mistake that might happen is forgetting to include the parentheses around the derivative of the inside function. This notation would say that the 2 is not multiplied to the rest of the expression, but in fact it absolutely has to be multiplied to everything, so it's very imperative to put parentheses here. Another mistake that's common is forgetting to plug g of x into the derivative of the outside function. If I had made that mistake, I might think that the answer would be 4x cubed times 6x plus 2, and that's not true. So we need to make sure to follow each step completely, keeping in mind step 2 actually has 2 parts. First part is finding the derivative of the outside function. The second part is plugging the inside back in. Let's do some more. Let's try another one. So we have h of x equals sine x quantity cubed. So the entire sine x function is being cubed. Another way to see this is sine x in parentheses with a cube outside of it. That'll make it easier for us to identify the inside and outside functions, maybe. The inside function looks like sine x this time, and the outside function looks like x cubed. Now this is pretty similar to the first example we did in this section, except for we've reversed the inside and outside functions. Notice that if I do fog, where g is plugged inside of f, I get back the original function here. But if I were to reverse this to do g of f, this time I'm plugging f into the g function. I get sine of x cubed. These two things are not equal to each other. They're quite different, but they're easy to confuse each other. So make sure that you know the difference between cubing the entire sine function and cubing the argument or the input of the sine function. They're not the same. So in this case, we're cubing the entire sine function. So step 1, we identified our inside and outside functions. Step 2, we're going to take the derivative of our outside, which is going to look like 3x squared. Then we're going to plug g of x into that so that we have 3 times sine x squared. Moving on to step 3, we'll take the derivative of the inside function. Derivative of sine x is cosine x. And then step 4, we're going to multiply the results from step 2 and step 3. Now something that I see when using the chain rule is that if we're comparing our original function to the derivative, with practice, we don't really have to write out steps 1, 2, and 3. With practice, you'll start to see the inside and outside function without having to write it out and without having to check it. Now don't rush yourself through that practice. It's very important to practice, and once you start to get it very quickly, you can skip writing down step 1, and you can jump to step 2 And you can even do step 2 without writing a lot down. What I mean by that is if we look at this as sine x quantity cubed, I can see that the outside function is the cube function. So taking the derivative of that almost looks like this. If it were just x inside, it would look like that, but we know that we have more than just x inside. We have sine x inside, so I leave it there. And then I multiply by the derivative of the thing that I left inside. So with practice, you won't have to write out every detail for finding the chain rule derivative, but using these steps will help you think clearly through the process so that you can do this quickly later on.